This video is an introduction to redox chemistry at A-level. I'd like to start by making sure that we're all coming from the same place at GCSE. So, oxidation reactions are something that we should all be quite familiar with. Combustion's a good example. I'd like to start by looking at the reaction with sodium and oxygen. So if I take a piece of sodium metal and I burn it in oxygen, I will make sodium oxide. And we can see in this reaction that sodium has been oxidised because during the reaction it has gained oxygen. But as we saw at GCSE, this is a very simplistic way of looking at oxidation and reduction. To look a little deeper, we need to see what's happening to the electrons, because chemistry and chemical reactions are all about electrons. So what happens to the electrons during this reaction? Well, in order to look at the electrons, we need to break this equation down into two half equations. So during this reaction, sodium goes from being an element to being an ion in an ionic compound. Oxygen also starts off as an element, but it ends up as an anion in sodium oxide. Clearly, electrons have moved. So if we split this reaction up, we could say that sodium goes to form a sodium ion, and in the process, it loses its outer shell electron. Oxygen, on the other hand, so if I take my half O2, gains electrons to form an oxide ion. We came across the shorthand oil rig at GCSE. Oxidation is loss, reduction is gain, and we're talking about loss and gain of electrons. So we can say that the sodium has been oxidized because it has lost electrons during the course of the reaction. We can say oxygen has been reduced because it has gained 2 electrons to form an ion during the course of this reaction. Put these two half equations together and we have what we call a redox reaction. Oxidation and reduction happening in the same chemical reaction. Let's take another example. Magnesium reacting with chlorine. So, to make magnesium chloride. Once again, if I look just at the equation here, it's not immediately obvious what has been oxidized and what has been reduced. We need to break it down into half equations. So magnesium during the course of this reaction loses 2 electrons to form a magnesium ion. Loss of electrons is oxidation. And the chlorine has gained electrons. Each chlorine gains 1 electron each to form 2 chloride ions. So we've got oxidation and reduction. We have got a redox reaction. What else is going on in this reaction? We can deconstruct it a little bit further to look at the role of the magnesium and the chlorine. We can say that chlorine is acting as an oxidizing agent. It is causing the magnesium to be oxidized, and in return it is reduced. The reactive halogens, so fluorine, chlorine for example, are particularly strong, powerful oxidizing agents. They're very good at being reduced. They're very good at taking electrons off something else to fill their outer shells. On the other hand, we can say that magnesium is behaving as a reducing agent. It is causing the chlorine to be reduced. Reducing agents and reactive metals, again, powerful, strong reducing agents, are very good at giving away their electrons to something else in order to reduce it. This can easily become confusing, so you need to hang on to one explanation and then run all your thinking from that. So I like to think of in terms of reducing agents giving away electrons. Oxidizing agents are very good at taking on electrons. So this system of writing half equations to decide on oxidation or reduction works really well for simple reactions like the two we've just looked at. However, when we're dealing with non-ionic compounds, organic molecules, polyatomic ions, so I'm thinking things like the sulfate ion or maybe the manganate ion, where we've got more than one element within the ion, writing half equations to follow the electron transfer isn't possible. So we've come up with the concept of oxidation states or numbers, and that's where my next video is going to pick up. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free math skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.